Clear to you all? Now the definition of other important terms in a electrical AC quantity. So one is the peak value and other is the RMS value. So say for example, if I am having AC value and which is having peak of let's say 325 volt, this is the peak, this is the voltage over time, and with our frequency, supply frequency is 50 hertz in India. So our period will be 1 upon frequency, so it would be 1 upon 50, so it is 20 millisecond. So it would take 20 millisecond to complete one cycle. Now if I am looking for peak value, so what is peak value? It is the maximum positive value. So here it started from 0 and it reached to maximum peak value. So this is the maximum peak value, okay, of sinusoidal AC supply is known as the peak value of the signal. So our peak value is 325 volt. Is that clear? Okay. And what is the RMS value? So RMS is also known as so R stand for root mean square. So RMS is also known as a root mean square value. So how to define this RMS value? So see here this current is every time changing in the instantaneous way. Sometimes it is positive, sometimes it is negative. But let's say if I connect such kind of voltage, let me just add one more page so that you will get an idea. All right. So in order to understand the RMS value, let's say this is my current versus time. Now here if I am having 10 ampere value and this is minus 10 ampere, okay. Now if I have one source with me and if I connect with a resistor, and this is the current I which is flowing through the resistor. Now we know that heat will be produced and heat will depends upon the square of current into resistor, I square R, right? So it is proportional to I square R. Now it, see, when we say positive current, so let's say this is my AB terminal. If we say positive current, it means that current is flowing from A to B, and when we say negative current, so current is flowing from B to A. Here it is important to notice that whether current flows from A to B or B to A, it will always produce an heating effect, okay. So while I am calculating the overall impact, so I should not consider that if current is negative then it is not going to produce any heating current. It is not like that. Irrespective of the direction of current will always produce some heating effect, and that we always have to consider. So RMS value is the equivalent DC current, okay. So let's say if IRMS is some DC value of current or equivalent DC value of current, okay, which is IDC square into R, okay, so which produce the same current. So let's say this for the 10 ampere, I don't know what will be the DC value, so let's say this is the RMS value of current, okay. So when it flows through the resistor, so it will produce the same amount of impact. Now in order to find this, so what I will do is I will consider the effect of individual current. So say for example 0 ampere, this is 0.1 ampere, this is 0.3 ampere, here let's say 5 ampere, let's say 9 ampere. So I will take square of all this current and multiply with a resistor, okay. So in short, what I will do is this is my I1, I2, I3 and so on, all the current. So I will take a square of all the current, okay, and I will also consider the negative values of current as well. And what I will do is I will add, let's say this is I7 and this is I8, I9, I10, all the current, okay. So I will get precise value if I reduce the step. This if I am going closer and closer, so I will get the more accurate value. So then I7R, I8R, if I add them, so this will gives me overall heating effect, and this overall heating effect I will replace with only one current, which is the RMS value of current into R. So this is the RMS value. So in short, what is the RMS value? It is the root mean square value. It is also equivalent DC current, which would produce the same heating effect which produced by the AC signal. Okay. All right. If you go next, so there are three types of power. One is a real power, reactive power, apparent power. So what is real power? See, when we do so real power, it is a component of apparent power. Okay, so this apparent power is sum of active and reactive. Let's say this is my active power is P, reactive power is Q, and apparent power is S. So S is nothing but P plus JQ. So the active power is the component of this apparent power, as well as reactive power is the component of apparent power. Okay, so it is the part of apparent power. Apparent is the total or whole power, right? So what this power, so while we write its definition, while we try to understand what exactly which power indicates, so reactive power is something where we have to understand that this is the component of apparent power which produced heating effect or lightning or even production of torque at motor shaft. Okay, so those all are like heating is if you connect your source with a heater, so it will produce an heating effect. So this is the real work, okay, that we want. Okay, if you want to boil our water, so what we will do, we will connect our heater with a supply, so then the energy will get transferred from the source to the heater and then heater to the water. So this is the useful work. Similarly, if you switch on your lightning load, so this is again kind of illumination that we are getting, and this is also kind of useful work. Even sorry, if we connect our supply to any motor, so at the time what will happen is, so motor will start rotating, and when we connect our load with a motor shaft, so load will also rotate. So we will have this rotatory motions of, let's say, pumps, or that's how we are doing some useful work. So majorly this power or any electrical load is having three roles: to produce heat, to provide the illumination, or to produce a torque actually in a motor. And by producing torque we achieve various tasks, right? Say for example, in EV, by producing torque we move our vehicle forward. With the example of electrical pump, so while it rotates, so it will pump the water from the the kind of bore or deep well to the heights or the desired location. So whichever power which is really producing the useful or the real work is known as a real power. Okay. And what is reactive power? So reactive power is the component of power. So see, in order to produce a torque, we require a magnetic flux. Okay, so there are two things which are important: magnetic flux or electrostatic field. Okay, so this magnetic flux is related with inductor, and electrostatic field is related with capacitor. So the component of power which is used to produce magnetic field or flux or electrostatic field is known as a reactive power. So in order to produce a torque, what we require to produce, in case of motor, what we have is stator and rotor. So so while you supply it, so there will be a rotor flux and stator flux, and it will interact with each other, and based on its angle the torque will be produced, right? So in order to produce a torque, this part, the field part, you cannot avoid. So in order to even produce the magnetic field, you will require some some amount of power, and this is also known as a reactive power. Okay, so while you are writing the definitions of reactive power, you should mention that reactive power is something which is used for producing magnetic flux, which is in the case of inductor, as well as which is used for production of electrostatic field, which is in the case of capacitor. Okay, so the apparent power is the sum of two power, active as well as reactive. So it is the total power. So it is related with active as well as reactive power, P plus JQ. So it means that P is having 0 degree and J is the imaginary part. Basically when we say J it is imaginary, which is not real or something like that. But technically if you just look at this J, so or the any imaginary part, so it is just expressing the 90-degree angle. So it means that if I am having P component, means active power component at 0 degree, so I will have Q component, means at the 90-degree angle, and the total power, which is apparent power, will be here. So this will be the phi or theta. So this is active at 0, reactive at 90, and this is my apparent or the total power. Okay, and this angle phi will determine the power factor. If I take cosine angle of phi, so this will gives me the power factor. So my power factor is the cosine angle between the active power as well as apparent power. There are various definitions of cos phi, power factor, which includes the angle, cosine angle of cosine angle between voltage and current. Okay, and as well as cosine angle between active and reactive power. But I hope you understand where exactly the various power are associated. Active power is related with heat or torque or the illumination. So basically it is related with a resistor. The reactive power related with magnetic flux, which is related with inductor, and as well as it is related with electrostatic field, which is related with capacitor. Okay, and apparent power is this like phasor sum of active as well as reactive, and which can be expressed as like this, and the angle between active as well as the active and the apparent power will gives you some angle, and if you take a cosine angle of the same, it will gives you a power factor.